All right, so we'll get this started. We are from Cloudflare, and our talk is a novel SIEM that doesn't cost an arm and a leg, kind of like some lessons learned as far as building it yourself as opposed to going with an off-the-shelf product. So my name is Derick. I'm an architect at Cloudflare. I kind of work on infrastructure and do a little bit of everything. And Phil is a senior engineer on our security engineering team, focused on detection and response. We are based out of Austin, but we have folks pretty much all over the world now, and we're constantly growing. So before we get started, I wanted to do a quick slide on who we are and what we're doing. It'll kind of bring into context a lot of decisions that we made when it came to building this out as opposed to going with kind of like an off-the-shelf product. So for those of you who've heard of Cloudflare, a lot of you have heard of kind of like a lot of the defensive stuff that we've done. We're a security company. We've defeated a lot of like the biggest DDoS attacks in the world. Some of you might be our current customer, use some of our WAF products, use our DNS resolver. But the idea is that we are growing as a company consistently, and our network is constantly growing. We're located in 200 cities in more than 90 countries. We handle over 1 billion unique IP addresses daily, 20 million plus internet properties, and a lot of Fortune 1000 customers. Our mission is to build a better, safer, faster internet. And with that growth, it always comes at a cost. And the cost for us is that we generate a lot of logs. We collect a lot of logs where we were collecting gigabytes before, now it's turning into terabytes and eventually be petabytes. So we collect all different types of production logs as well as internal logs, whether it be on the infrastructure, OS query, audit subsystem, application logs, syslogs. Things are kind of consistent with what a lot of people are collecting these days, as well as internal logs, IAM, DNS, endpoint systems. So from a security analyst perspective, this is really good. It's always good to collect a lot of data, make it really rich, and obviously be able to weed out what you want to see and kind of see what's considered anomalous. So, the question comes, where do you put all these logs? Generally, you might have like an existing elk stack, which we found internally we're able to do, but, how do you then analyze that? And a lot of, the answer to that usually is some kind of SIEM. It's what everybody uses. It's really good. Your detection and response teams use it in order to be able to analyze all the data, catch bad things, yada, yada, yada. But what we realized is it really didn't work so much for us at scale. I mean, we're dealing with a lot of data and a lot of kind of differential data, especially when you're dealing with things like OS query. You're looking at a previous state of something that is considered known good or known bad, and then you're doing a lot of differential data based off of that. So it didn't really work well for us. So we kind of developed this high-level overview as far as what we were specifically looking for. And it's, a lot of people kind of tend to do this, but it's just, gathering log sources from one side, ingesting it, finding ways of either enriching it or decorating it, and then creating some kind of alerting process. So the idea is that you're just trying to funnel out all the bad events, all the stuff that you really don't want to see, into things that are more or less actionable and relatable. So with that in mind, if we were to go back to the original design, when we were looking at a lot of the off-the-shelf products, what we determined is that it didn't fit specifically with that model, especially with our scale, because without naming any names, typically you would have a central ingestion point within a specific region where you're kind of like aggregating all your logs, and from there you can enrich them, you can filter them out, you can perform some kind of ML process. But the idea is that we would have to replicate this all over the place. So you might be able to control central search, from a central location. But the idea is if we were trying to get real-time analytics, we were going to incur some kind of delay, especially if we had to have these central ingestion points all over the place. So for us, it really didn't work. So we developed a set of requirements. Accept logs from a global network with minimal latency. Separate our infrastructure from production. Obviously, if our infrastructure went down, we wanted the ability to be able to still have our events data still coming in to determine exactly what happened. Send alerts on detections, searching the logs, extendable long-term storage. All pretty much makes sense. It's all pretty much requirements that pretty much anybody would have. But what if we didn't have servers? What if we got rid of the underlying hardware costs? What if we didn't have to tax our existing SRE teams to manage it a separate set of hardware? What if we didn't have to do it internally? It seemed like we would eliminate a lot of these hidden costs. So we made that a requirement. Let's make this serverless. Let's determine how much we could do without actually having any type of underlying infrastructure. So we pitched this idea, and people thought we were crazy. I mean, it's complete madness. How are you going to do this, efficiently? Everybody who's familiar with SIEM technologies usually has some kind of underlying hardware technology. But, we're crazy. We like doing stuff that's fun. So we decided to look at GCP. We were like kids in a candy store because we had all these great services that we could use that didn't rely any type of underlying hardware costs. We didn't have to expend any type of compute. It would scale really well, and especially for things like storage, we didn't have to worry about adding attached volumes or existing persistent storage. It was also written in Golang, and it had a lot of rich documentation. So we kind of drew out a rough chart of what this would look like, and there's a lot that goes into this. But at the core, we use a message queue in the form of pub/sub. It allows us to be able to deal with everything effectively, efficiently, and in real time. And because we're serverless, we use cloud functions all over the place in order to be able to, they're quick to write, they're quick to deploy, and they're invoked in cloud runtime. And then we use different types of log aggregation where we're using GCS buckets as well as Stackdriver, so that we can look in them, filter them, search through them, and whatnot. And then we're using a variety of other things like SQL, DB, Redis, key management, source control, all pretty much natively within Google. So you can Google this image, how to draw an owl. Obviously, there's a lot of steps that take between going from 1 to 2. So and the reason why we do this is because there's a lot of components that went into this. It wasn't just as simple as just kind of having a rough drawing. So it looks simple at this, but when you look at this specific pipeline, it looks a little bit more like this. So might be a little hard to read, but the idea behind this, just for cold storage, is that we have ingest functions, and from there, it's a log identifier that determines, based off of conditional, if it's a new log type, assign a new log type, create a new BigQuery sync. If it is some existing log type, add to existing log. So the idea behind that is there's a lot of different components that went into this. So when we took that high-level overview again and kind of revisited it and fully drew it out, really hard to read. But this is what it looks like. You have a bunch of different log sources on one end. You have this ingestion pipelines that are created, the detection pipelines that are created. And again, that kind of like that funnel sieve type scenario where you're funneling those events down into actual alerting and actionable items. So I'll hand it over to Phil, where he will actually go into it in a little bit more detail.
Yeah. Also, apologies, I made these slides. I didn't realize they were going to be that tiny, so feel free to hit me up afterwards. So there's a lot of similarity between how we kind of process a bunch of these different log types. So I'm just going to kind of break down, kind of focus in on one that we use pretty often. So we use Corelight pretty heavily. Corelight is a commercial version of Zeek, formerly known as Bro. So we'll just kind of start with this sort of first diagram, like how do we get the logs actually into GCP for further processing and normalization down the road, right? So we got to support tons of different log files coming in. We have our own Cloudflare logs for various sites that we host internally. We have all the Corelight logs, but there's a lot of ways to get that data in, right? You can pull directly from an API. Maybe some vendor uploads something to a GCS bucket. Maybe we have to write something to publish to an HTTP endpoint. So we kind of need to support all these things. Kind of a different way to put it, as Derick said, all the log files coming in the left side, coming in the right side. But we needed to sort of standardize on a kind of a way to process these further down. So we decided, hey, everything's going to go into pub/sub, which is basically Kafka. It's a message broker. The cool thing is you can hook in background functions on there so you can process every single message as it comes in, right? And it's with a guaranteed at most once delivery. Anyway, and then the other thing was we wanted to make sure every single event is written Stackdriver. Now, Stackdriver is this thing that Google has. It's kind of like Kibana front end. The great thing is it's free to search. You get free 30 days of retention. You're basically only paying for the API write calls. So now we got a bunch of logs flowing in. We want to kind of start interrogating our data, right? Lots of different questions. Does this match some sort of known malicious signature? Is there a good threshold on this metric that's coming in? Is this some sort of new behavior we're seeing, like some kind of increased DNS query to some Russian ASN? So kind of thought about how do we trigger these detections, right? We kind of came up with 3 sort of techniques. The real-time or tripwire detections, these are powered by cloud functions that a bunch of our analysts can write. Things like malicious J3 signatures. I guess we're going to have to implement those JARM signatures that they were talking about. And then we kind of group these other ones like batch analysis. This is based on BigQuery, but it lets us sort of query terabytes of data across various time periods, multiple sources, correlate a bunch of stuff. We just hired data scientists, so we're going to start looking into this ML stuff. We'll definitely present more on that later this year. So, yeah, as I mentioned, the real-time rules, the tripwire rules, these are all cloud functions. They're written in Golang. Any message that comes into any pub sub topic triggers an invocation. They're really fast because we write everything in Go. Go routines give us really easy concurrency. So it scales really, really well. We started implementing this, I don't know if you guys have heard of it, it's called the Common Expression Language. It's this toolkit that Google provides, but it's basically a way for analysts to sort of write some of these rules in a more sort of English-like language versus having to write straight-up Go code. And it allows us to onboard a lot of people a lot faster without a deep developer background. This is not working. Oh. Next up, we have what we call our sort of batch rules. These are a lot more complex queries that can come in, and we can interrogate events, across multiple time periods, across multiple data sources. And then, of course, the best thing is we can just use standard SQL syntax, right? So basically, all the events are written to BigQuery as they come in from Stackdriver through what they call an export or a sync. And then we have a couple of cloud functions that will take rules that we've written in this YAML format and then apply them. Here's what a sort of example rule looks like. So you can see it's just simple SQL and then a couple of extra fields that we'll process there, like how often do we want to run this rule, what playbook do we want to call, and that sort of stuff. Yeah, so anyway, once we got a rule that's been triggered, it goes into what we call our sort of raw detections message queue. This includes everything. This includes false positives, which we'll later discard. Events that might need further enrichment from various threat intelligence sources. Basically anything we want to do with what we consider a possible detection. Because it's in a queue, it's super flexible, so we can kind of route it to wherever we want. Right now, we just have a pretty lightweight function we call sirens. It's basically an alert router. If you saw the Atlassian guys' talk yesterday, it's kind of sort of the beginning of their system there. We're still kind of fleshing this out a little bit. But anyway, it'll pull messages from this pub sub, which has that standard alert format, route it to either PagerDuty or Jira or GChat. We're going to have a lot more subscribers coming in the near term. Chronicle just open source their API. We want to kind of tie in Carbon Black and that sort of things. Yeah, I mean, here's an example of a real alert we got. Took like 15 seconds for one of the analysts on call to go in there and check it out. Yeah, so let's finish up with a little bit of what we learned and has this been worth it so far. This is pretty much a primary detection response pipeline right now, doing around 5 terabytes a month. Probably going to do 10 to 20 more this year. It's about 50%. The most important part, or the most expensive part, is the API write cost of the Stackdriver right now. But sort of once they're there, we don't really have to pay for storage. And the cool thing is we're about 50% cheaper than a lot of traditional SIEMs that we investigated earlier. Huh? 50 times cheaper, sorry. Yeah, that's a significant. Yeah, it's coming up next. Ton more event sources coming in. We want to make it easier to sort of write rules of, sort of specific types like spikes in a certain activity, frequency analysis. And we have a lot of data analysis tools that we want to sort of drop into this raw data. And again, of course, also adding a lot more threat intelligence sources. Something else I'm really interested in looking at, I know a couple of other organizations have done this, but we thought it'd be pretty cool to potentially automate a lot of our playbooks using Jupyter notebooks. If you're not familiar with Jupyter notebooks, they're a way to sort of have code and documentation sort of side by side along with visualizations, and then run them at a certain time. So basically, by the time a human being potentially looks at a detection, we could have already done a significant amount of work. This is just like a cool little anecdote. It was one weekend, and we accidentally turned on a new log source. We had been averaging about 20 gigs a day, and suddenly we were pushing an additional like 9 terabytes over the next 4 days. The cool thing was it scaled up automatically. We didn't have any data loss. The additional cost was only about $3,000, and that was that's without like any Google coupons or what have you. So we didn't get into too much trouble for that. Yeah, and then of course we also plan on open sourcing this. I'm currently working on some Terraform things so people could easily spin this up and play around with it. It's just not quite ready, but we're kind of targeting mid this year to do all that. Yeah, I guess I kind of talked pretty fast. So if you guys have any questions, feel free to ask.
Are you doing a SIEM, sir?
What's your team size, and how many people do the care and feeding of this beastie?
So it's primarily my team that's doing this. There's a couple of other parts that other teams are working on, but it's like 6, 7 people. I would say full-time, kind of working on this, maybe 2 to 3. Obviously we know that's not going to scale, but as this gets more complex, but we'll figure it out.
Other questions? Cool. Okay.
Cool.
Awesome.
Well, thanks.
Thank you.